All right, hello everyone. Welcome to the analysis meeting on May 3rd, 2022. On the agenda for today, we have our usual check-in, and then I will talk about the final MLA configuration, along with how we plan to strengthen the airframe. Then I'll talk about the avionics base crew calculator and some updates from today as Omar was working on it. And then just another reminder about the recovery calculator cleanup and optimization. And then I'll assign you guys some stuff to work on for the technical report, and we'll split it up just by projects and then just start drafting them as they come up. So just the usual, some recent progress that you've made with the team, and also what are you looking forward to in the summer, but it can't be engineering team or school related. Something fun with our miserable lives. I want to hear.
All right, I get started off. I think the thing that I'm looking forward to the most, besides competition, is just exploring a new city in Seattle. So kind of living on my own for 3 months and seeing how that's going to be, I think is pretty exciting.
Nice. Jealous of Seattle. Right, yeah, for me, I've just been trying to help out with the MLA FEAs and just determining what that system is going to look like in its final configuration. And also just discussing with Omar the screw calculator for the avionics bay and looking at if we can reuse Oberons or not. I am looking forward to living on my own in the summer in the great state of Alabama. If I do manage to survive and come back, I think I deserve a medal. So we'll see what happens, but looking forward to running for my life. All right, on a more serious note, the final MLA configuration. So the CAD, this is thanks to Arturo, big shout out, but it is a little incorrect just because of the 1 inch gap here. I think it will be better if we just put the centering ring pretty much like right on top of the fin, because we're just losing out on potential load that it could be supporting by moving it further and further up. I do want to put this in open rocket and then see if that 1 inch makes a big difference with stability. I highly doubt it will. So that's why I think we're just gonna put it next to the fin. But the full list of components, just the 25-inch motor cover, the green tube, the bottom centering ring, which you can see is a little thicker at 0.75 inches. It'll have a total of 8 1/4-inch 20 screws. And the inserts and the hole size are still to be determined. I think once we obviously know what inserts we want to use, then we'll have a corresponding hole size. And then from there, which I'll talk about in the next slide as well, we can find the correct bushing size. But this also includes just one top centering ring, which is 1/2 inch thick directly above the fin. And that will have 4 1/4-inch 20 screws. The inserts and the hole size to be determined as well, and then the 4 fins. And as we know, the components, all the components will be epoxied to this motor cover, and planning on using chopped fibers with mixed epoxy for more strength. Thank you, Arturo, for your comment. But yeah, for the MLA, I think also I want to see how these holes line up and make sure that we're not going to be on top of, or I guess the holes would be like on the same vertical axis, but also maybe looking at the drag induced by having a bolt right in front of the fin. I don't know if there's complications there, but maybe we can try and shift it And then I think also the location of the eventual rail buttons will also have an impact on just the way we orient each of the centering rings. So not final, but from our end and the things that we can control and determine, I think we're good. Now for the airframe strengthening method, I think these are the two most feasible options of reinforcing the airframe holes. If we use chopped fibers mixed with epoxy at each separate hole site, that'll allow us to reinforce the airframe just at the points at which we know there's going to be some high stress. But something a little more well-rounded would be a few wraps of carbon fiber or fiberglass on the inside. I'm not sure at what point the number of wraps becomes enough to start impacting our tolerancing and fit with the centering rings, but hopefully we can get enough wraps to where it doesn't impact, but still adds a good bit of strength and reinforces the airframe. And then the bushings, I think we should definitely use these on all of the MLA screws. This will allow us to reduce those point stress concentrations from the thread on the airframe. And then we can cut down however long the bushing that we buy is to match the airframe's wall thickness so that it doesn't protrude on either side. And you're able to just have like a little, I guess, like secure part so that the thread doesn't touch the actual fiberglass of the airframe. So I left the link to it on the MasterCar, and it's also on the Discord somewhere from yesterday's message. Yes, Irvin. Yeah.
I spoke with Gustavo earlier, and he did mention he had a concern about using the bushing method and it not being able to hold in there since epoxy doesn't really stick to any metals. I don't know if he brought up that concern to you.
Mm, I haven't thought about that, but I think we may be okay if we're able to make a hole size in which we can press fit the bushing and we don't have to worry about it coming out. Because also that bushing is going to be held down by the head of the screw or the head of the bolt too.
Okay.
And then it'll be held in from the inside by the centering ring pushing on it.
Right.
So I don't think we'll need epoxy to like glue it in place. If we can just like pretty much just sandwich it.
All right.
And then also just have the tolerance low enough to where we can press fit and it's going to be hard to get out.
Okay. Another thing I was thinking about, and I guess this is more of like a structures problem, but just something to consider, is right now, and I guess we asked this yesterday to Gustavo how he wanted to put both of the like a third of an inch plates together.
Yeah.
If you do that, how are you drilling those? Are you just gonna drill the holes for the bolts to go into the centering rings, right?
Mm-hmm.
Wouldn't that just be pushing on the top one, like if it's going down?
Yeah, so I think the plan is to obviously sandwich those two plates on top of each other. And then I think we should.
If you do this and you're drilling, I know they can't see it on the screen right now, so
Yeah.
I'm explaining to you, and you go like that, you're like almost
separating
them, and then any force that goes whenever it lands, it's just pushing the top one. I feel like you're losing strength. What are you doing that?
Yeah, if you can't see what Irvin said, he pretty much just if we have one plate of the centering ring and from the lab and then another plate on top of it, and then we try and drill a hole in between those two, then when the screw is going to be placed in there and the insert, and then say we land and that screw wants to push up, then it could just lift off that top plate and then we're pretty much screwed from there if that happens. But I think there are different ways in which you can epoxy kind of two surfaces together, because we did that with, I know it's different, but Oberon's wooden centering ring. We had 3 different layers and then drilled through the middle of it, and that held up fine. I know it wasn't load bearing, but the screw is definitely not going to be like pushing on the wood too much. So I think the insert can really help with that. But I do think it is definitely a concern, and we do need to figure out, I guess, structures, is to figure out how we're going to combine those plates,
Okay.
because that's definitely a valid concern, and maybe it's something we can ask. Yeah.
Okay.
So just so I was like understanding, right? So wouldn't the fact that the centering rings themselves are epoxy to the motor sleeve, right? So both of them are already epoxy there, and then the screw, like let's say the landing load happens, right? Is it really going to be trying to press it apart, the 2 plates? Because like the screw isn't going to be pushing. Oh, sorry.
If the hole is going to be drilled in pretty much the middle of that sandwich, then that upper half of the screw, which is the upper half that's going to be experiencing the force, is going to want to move, or more realistically, the top of the centering ring, top half, wants to go down, and that screw wants to stay in place. So that separation between, I guess, if like this is the motor cover and this is the centering ring attached to it, like here, then it could sandwich. So it could still be like attached to the motor cover, but you could still have it lift off and then disengage from the centering ring. I don't know if that makes sense visually to y'all, but you can try and draw it out and see what happens as well. So for the screw calculator, huge shout out to Omar, who's been taking charge and working on this. He came up with kind of the forces that the avionics bay will experience throughout the launch and throughout flight. The first force to consider is obviously it's going to be supporting the dry zenith mass, which we have right now at around 53 pounds. It will also experience the main parachute snatch force, which is at just under 143 pounds. The drogue parachute snatch force, which is lower at 77 pounds. But then also the landing load, which we have at 3,000 pounds force. And that was calculated by using the weight, the projected weight of the avionics bay, and then simulating kind of that same landing load, but only looking at the upper airframe and the fact that the avionics bay may want to move down the airframe while the screws are holding it in place. So that was around 3,000 pounds force, which is easily, I think, the most that we project the system to experience, worst case scenario. We determined that we needed 9 number 8 screws with a factor of safety of 2.5. And we kind of, I guess, manually fidgeted with it as well, because there are currently 9 holes on Oberon's avionics bay with 3 rings of 3 screws each. So this lines up pretty nicely, and we're able to reuse Oberon's bay actually. I think we will still need to reinforce the avionics bay, kind of the same method of the wraps on the inside of the bay, because if you can see the picture, these kind of horizontal lines in each of the holes are actually the individual fibers of the fiberglass tube that are starting to come undone. And that makes like each hole point a lot weaker and a lot more susceptible to failure. So I think repair is definitely needed, but the good news is we don't need to order another coupler in avionics bay, I think we'll still be able to use Oberon's and be completely fine on supporting the max load that we expect to experience. The calculations are a little rough just because we don't know the exact weight of the avionics bay right now. I have reached out to Raj and Joe to try and get an updated number on that. But yeah, once we assumed 2 pounds, so hopefully it's around there. And I think if it's a little heavier, then we'll still be fine with 9 number 8 screws. It's just that the factor of safety won't be exactly 2.5, but I feel like that is already at a good spot where we can sacrifice a lower factor of safety a little bit. All right, recovery calculator cleanup. So this is just kind of the same from last week. I just wanted to let Amy know, if you're watching the recording, that I plan to talk to Carlos sometime this week. Hopefully he can come into the lab tomorrow, but I'm not sure. And then once he talks to me about it and we can learn more about the calculator, then we can start to actually get some more work done. But thank you for coming into the lab yesterday and getting started on it already. I appreciate it. Okay, the tech report assignments. And the main part of what I want to talk about today. I just wanted to provide a rough overview of what analysis is responsible for on this document. We have an overview of our subteam. We will be talking about the Zenith flight simulations on both OpenRocket and RockSim, the nose cone drag simulations, so the code we built for the OpenRocket drag force, and then also the CFD and whatever Nico can provide us on that end. The boat tail drag simulations, that was just a comparison that I wanted to have to justify the use of a boat tail without just saying, hey, we saw another team use it and it works. So hopefully from there, Nico can do a side-by-side of a simulation with the boat tail and without. The overall MLA, so explaining the entire system, also working in the validation of the screw calculator and the FEAs. I think will also be cool to talk about kind of the different iterations that we had and why we made major changes and how we ultimately ended up at our final product. The fins, when we did the flutter and divergence calculations through Aerofin Sim, but also designing for stability and mentioning that. And then I know recovery has a ton of analysis and validation that we haven't really helped out on this year. So I think it would just be cool to offer some help if they need help there, especially if we're going to be incorporating ourselves with their calculators, then we could offer some help to provide validation for their system. So I plan on beginning work on this tomorrow, and I can set up a separate document just for analysis so we can all add our own figures and work into each section. But generally, you'll be responsible for the projects that you worked on. I'll try and help out with everything and answer any questions you guys have and work on formatting and making sure things come across the way we want to. But for the assignments, I'll take care of the overview and then be helping you guys on everything else. The Zenith flight sims, Amy and Will, we were the main ones working on that. And then the nose cone drag force, that was also Amy and Will, and then Nico for the CFD. Nico, I have your name in red just because I know you're extremely busy this week. And if you could just provide us with the CFD, and then maybe I can talk to you one-on-one about the results, but then we should be able to incorporate it ourselves and then talk about it as well. The boat tail drag simulations, Nico there, and then the MLA with Arturo, Omar, and Prith, and the fins with Amy and Will. So definitely don't feel limited to what I've assigned you, and I will help you out because I know we're all busy this week and with finals. The final due date for the tech report is the 13th. However, we do want to have it completely finished by the 10th of May, which is next Tuesday in 1 week. Yeah.
Or at least
So
year, like the sub team section.
yeah. So have all of analysis in our section complete in 1 week, which should be pretty easy. Honestly, I think we have been doing this stuff the entire semester. I think we have some really good documentation for some of the earlier stuff, and the recent stuff is things we've been working on, so it shouldn't be too hard to talk about and justify. But yeah, all the hard work I think throughout the semester is going to be on this document, so make sure you represent what you did well. Don't, I guess, feel free to provide as much validation as possible. I think the judges will love to see that, and showing that we've thought about things that other teams maybe didn't could win us more points in the end. So it's time to show off why we were created and hopefully do well with the report. Yeah, any questions for today? How long does judging take? I don't know. I don't, because we submit the like tech reports and all the documentation, obviously like mid-May, which is before, like a month before competition. So I think they will be able to tell us where we placed at the end of competition when we're there.
The award ceremony is 24th or the 25th.
The last day. Yeah.
Maybe the last day.
So cool. If there's no more questions, then I will end it here. Thank you all for coming. Good luck on your finals. And then just let me know what your workload is like and what can contribute. If you can work on anything this week, I'll be really grateful. But if not, please focus on your finals and do a great job. Thank you for coming.